This tutorial is to go over how to input your geometric data into HEC-RAS. If you remember what we talked about last time, we basically took our example problem, again 5.2 in the text, page 195, and we broke it up into different geometric components and basically fully described the three-dimensional geometry of the channel, how it varies with elevation, how it varies with distance across the channel, and what the cross sections look like. Again, this is a trapezoidal channel, bottom width of 8 meters, side slope ratio of 2 to 1. It's a straight channel, and it's prismatic, constant slope, constant cross section. So this is a good geometry to start with in HEC-RAS. And again, HEC-RAS is you're going to use river stations to describe the change in the horizontal distance and elevations for the change in the vertical. And all the numbers, this is what we went over last time. And so basically we want to get this geometry into HEC-RAS. Okay, so in order to do that, let's open up HEC-RAS. Okay, and we're going to start a new, go to File and New Project. So anytime you start a new project, you go here, and we want to save it somewhere. I usually go to the default project folder, which is my documents, HEC data, HEC-RAS, and I'm going to create a new folder for this. And why don't we call it example 5-2. Okay, and so in example 5-2, and I can call my project something similar. We'll call it example 5-2. So notice the extension PRJ, that's your project file in HEC-RAS. And so you just click OK, and it's going to give you a little notice here. It's going to start a new project with the name we gave in the folder, and it gives the file. It just takes the PRJ. It's going to be called example 5-2. And then notice it says here the units will be set to US customary units, but can be changed. So we know this is an SI problem, so we're going to change it. So go ahead and click OK, and then the very next step I want to do is change the units so I don't forget. Options, unit system. And so again, set to US customary, we want to set to SI. And click OK. And then it's just going to tell you it's going to convert. But since we don't have any data in here, this is not really a big deal. Okay, so just hit yes. And notice here were the units. It used to say US customary, now it says SI. And in the main window, we now have a project name and location. And basically, we need to start to fill in these other categories here, geometry and steady flow for our steady flow solution. Today, this particular proposal will focus only on geometry. So again, you can go to your edit geometry, edit geometric data, or you can just use the button, again, our little stream network, and it will take us into our geometric data editor. Okay. This is where we're going to do all of our work to set up our geometry. The first step we have to do is we have to define our channel. And that's this river reach function. So we're literally just going to draw a straight river reach that's going to describe sort of a plan view or a bird's eye view of our channel. So click on that. And then it doesn't matter how long or what angle or anything. You just need to draw a line and then double click when you get to the end. Like so. And it's going to ask you for a river name. You can call it anything you want. How about Big River? And reach. So you actually knew if there was like a USGS station or something, you might want to call this something, but just call it reach 1. We only have one reach for our particular problem, so that will be fine. And click OK. And you notice you now have a flow direction, you have Big River, and reach 1 is notated on here. Now you probably notice as I'm scrolling around here, there's some numbers changing. So there's a scale here, but we have to define the distances. HEC-RAS doesn't really know anything at this point other than we have a river of reach of some length. Okay, so where most of this, the excitement happens is in the cross-section editor. So click on the cross-section editor and it brings up this little window that we'll be very familiar with by the end of this tutorial. The first thing we need to do is start adding cross sections. So the first one I would like to add, if you remember in the last tutorial, we developed the geometry for the downstream end. So I would like to add that. So go to options, add a new cross section. Notice we don't have, a lot of the options are grayed out because we have no cross sections yet. So we need to add one, add a new cross section. and it asks you, enter a new river station for the new cross-section in reach 1. And so since we're doing the downstream end, if you remember, in fact, we can go back and have a look, we called the downstream end river station 0. And so I'm going to type in a 0 and click OK. And now we can start adding information about our cross-section. I often write a description particularly for my upstream and downstream ends. So I'm going to call this downstream boundary. And notice here river station is now 0. River and reach are noted here. And notice this is kind of, it's like this kind of brownish color because the data has not been applied. So after you enter new data, you need to hit apply data. And notice now it turns black, so everything is fine. Okay, now the excitement sort of happens here, and let's go through each of these individually. The cross-section coordinates, this is the actual geometry for the channel, the stations and elevations, which should sound familiar because in the last tutorial we used Microsoft Excel, and I'll bring the window up now, to define the station and elevations at river station 0, the downstream boundary. And the reason we did this in Excel, it's really going to pay off now because I'm simply going to highlight these, hit, well, you know what, I'll go ahead and do it so you can see. I'm going to copy it, copy, and then I'm going to return here. And you can't right-click to paste, but you can hit Control-V. There's my data. Notice again, it hasn't been input, so I can hit Apply Data. And now we see something very similar to what we saw in Excel. Okay, notice it tells you the project name, example 5.2, the description downstream boundary, and you see we go from a station of 0 to, and we follow our trapezoid as we developed that geometry in Excel. Notice also, much like Excel, the X and Y axes are not, the scale is not the same, so this is a 2-to-1 side slope with an 8 meter bottom width. Okay, and notice again our elevations, 0 is the lowest point, and if we go back to our sketch, 0 is the bottom of, elevation 0 is the bottom of our channel. So we're happy here. Okay, now in the right, this right-hand column here, we need to input basically information in each of these. The first one is downstream reach lengths. So this is the length from river station 0 to the next cross-section downstream. Now, since this is the downstream boundary, there is nothing downstream, so you can simply leave it blank. Okay, the next one, Manning's end values. Well, we know for this particular problem, it's 0.025, I think. Let's double check. Yes, 0.025. So we can enter that for the main channel. And then ROB and LOB stand for right overbank, left overbank. These are those floodplain values. And we can go ahead and copy and paste the same values. We don't have any floodplains for this problem. So you could see you could enter different values if you'd like. For instance, your floodplain might be quite a bit rougher. You might have something like this, right? Again, these values aren't going to matter because we're not going to have flow in the floodplains. Next thing are these bank stations. Let's go ahead and apply this data so we can notice that the figure, you might have noticed the figure turned red. That means you've changed data, but your figure has not been, the data has not been applied. So this figure is now out of date. We hit apply and notice it shows a value here for Manning's end. It shows 0.05. And that's because we haven't told HEC-RAS where overbank flow occurs or in the floodplains and where the main channel is. So we want to restrict the main channel between this next category, main channel bank stations. We want to restrict the main channel here. So between station 0 and 16. This region is our main channel. So left bank station 0, right bank station 16. Notice again it turned red, so we hit apply data. And now there are those red dots I told you about, bank station. And notice it's now assigned the correct Manning's end to our main channel. Okay, that is excellent. So we've now got our first cross section in. We'd like to now put our second cross section in. And where do we want to put that? Well, we have a number of choices. If you remember, let's go back to our sketch. So we now have a cross section here. With numerical methods, we solve at discrete distances along the channel, or discrete points along the channel for each of those cross sections. So we need to define those. So we could set a cross section, say here, maybe it's 100 meters, maybe 50 meters, input that geometry. We could do that some further distance and further distance, work our way all the way to River Station 1400, the end of our channel, and we'd be done. We could do that, but we can take advantage of some nice tools in HEC-RAS, and the fact also that our channel is prismatic, so constant slope, constant cross-section shape, and we can do this rather quickly. Okay, so the next cross-section I'm actually going to put in is the last one, the most upstream boundary, River Station 1400. And so the way I could do this is I could go back to options and add a new cross-section and put all of the information in. But if you notice, the next cross-section down says copy the current cross-section. So that's going to take all of that cross-section data and simply copy it to a new river station. And since this is a prismatic channel, this might be a nice thing to do because our cross-section shape is constant. So that's what I'm going to do. I'm going to hit copy cross-section, and it's going to ask me which river and which reach. Again, we only have one of each, and then river station. And I would like to make this the upstream boundary, so I will enter 1400 and click OK. And notice that it just put river station 1400. Now we need to change some things. We need to change the upstream boundary. We now need to add downstream reach lengths because we now have a downstream river station. That happens to be River Station 0. And if you'd like to see the different river stations, you can click here and it will show you all available river stations. So the distance from River Station 1400 to River Station 0 is in fact 1400. So enter it for all three. Main channel is the important one. Floodplains, these are the downstream reach along the right overbank or the right floodplain, the left overbank, left floodplain, and in the main channel. So if your river is completely straight, as ours is, these will all be the same. But if it has some curvature, the left bank may be larger or smaller than the right bank, etc. And we need to apply our data. We do that, and again, this was red, now it's not, and looks like we're good to go. I did mention this earlier. These contraction expansion coefficients, these are minor loss coefficients for expansions and contractions in your channel. But the defaults have been in general, I would go with the defaults unless you have a reason to change them. And we don't have a contraction or expansion in our channel anyway. Okay, so now we have two cross sections, and you notice there's two ways you can see the different ones. You can go to 14 and you can use the pull down menu to go to 0, or you can use these arrows. And since we only have two, we just toggle between them. Okay, now once we get the cross sections in, it's always a good idea to look at your data and see what it looks like. So you have some plot options. One is to plot the cross sections in a separate window. That essentially looks like this image. The other is to plot a profile, which again, that's a profile essentially shows us the bottom profile like we see here. So let's look at the profile for this channel, make sure we've got everything in correctly. And we go to plot, profile, and you see we go from River Station 0 at elevation 0. That looks good. But then notice at River Station 1400, we have no slope. So we've got to fix this problem. And if you look at this, the reason we have this is notice our lowest elevation is 0 at River Station 0. If we move to the next river station, 1400, our lowest elevation is still 0. So we did not shift our cross section based on the slope. And you can see that if we go back to our sketch, you can see you'd have one cross section here. The elevation of the bottom should increase, in fact, by 1.4 meters here. So we have two options. We can simply add 1.4 meters to each of our elevations. But HEC-RAS, again, has lots of tools for this type of thing. So we can go to options. And in the second group, these allow us to adjust uniform values on that cross section. So we're going to adjust elevations. So click on that. And it says enter amount to add to the elevations, plus or minus. So you could add or subtract elevations. In this case, we want to add 1.4 meters. This is going to take 1.4 and add it to every single elevation. If you look over here, we've got 2002. We're now going to add 1.4 to each of those. So click OK. And we have 3.4, 1.4, 1.4, 3.4. So we've done that. And notice it did not change here. It turned red. If we apply the data, though, it will fix it. And it kind of shifts. It didn't change the scale. But if we go back to 0, and we see, so again, River Station 0 starting at 0. And if we move up, River Station 1400. Now it kind of squished, the scale changed again. It squished it a little bit, but we see our basic cross section. And our stations and elevations have all been adjusted. Okay, so we now have 2 cross sections, and again, we might want to check the profile plot to make sure we got it right. So plot profile, and you see here a straight line. It looks good. We have a change in elevation from 0 to 1.4, which is what we want at River Station 0 going to River Station 1400. Notice that this is a mirror image of how I drew it, but it's again, the numbers are exactly what we want to see. And the ground, the black dot is your cross section, and then they connect it linearly with a straight line. So looks pretty good. Okay, so we're going to close this. Another thing I like to do at this stage is look at the data in a different way to make sure that I like how it looks. So I'm going to go ahead and exit the cross section editor. And this is a very good time. Also, notice now we have our reach 1 of Big River, and we have cross section 0 notice the flow direction at the downstream end, and cross section River Station 1400 at the upstream end. This is a great time to save your data. So go to File and Save Geometry Data As. This is our first one. So we haven't created any other geometry. So we're going to save it. Why don't we call it Geometry 1. Okay. And we're going to click OK. And it might be implied, since I called it Geometry 1, we might have a Geometry 2 at a later time. And the HEC-RAS is really nice and modular. It allows you to use different geometries and different flows for the same river. Okay, so let's go ahead and exit the geometric editor for right now. I mentioned in the intro to HEC-RAS that these buttons here were primarily for looking at results. We don't have any flow results, but this is a nice tool here, the 3D cross section, to just make sure you've got everything input correctly. So let's go ahead and open that. And oops, and you can see you can kind of play around with viewing your data. This is a good enough view for us. You can see River Station 0, here's our trapezoidal channel. River Station 1400, here's our trapezoidal channel. And so if you combine this with our profile plot, which showed us we had the slope correctly, I like what I see. I'm pretty happy with my geometry, and I'm ready to move on. The other thing to note is that we have 2 river stations, 0 and 1400, and we want discrete solutions at many points along this channel. So we want to add more cross sections between 0 and 14. Oops, oh, that does not look good. Let's go ahead and exit this. And as you might have remembered from what we just did, we could go back to our geometric editor. We could go to our cross section, say River Station 0, our downstream boundary, and we could copy this cross section, adjust the elevations, and move our way up the channel. And that would be totally fine. We would get a very good series of cross sections there. But again, HEC-RAS has a lot of tools to handle this. We're going to exit the cross section editor and go to Tools. They have a tool. The very first one is the one we're going to use, and it's extremely useful. Cross section interpolation. We're going to interpolate new cross sections in between the 2 cross sections that we just created. So I'm going to go ahead and click this. And the way this works is we need to select our upper river station. And so we want to select 1400. And so we want to interpolate cross sections in between 1400 and 0. And we have a couple of different options. One, we can set a maximum distance. For this type of simple problem, I like to use a constant distance. Use a constant distance. And then we can set this to, say, let's try every 100 meters. It's kind of an art form, figuring out what your cross-section spacing should be. Let's try 100 meters. And then if we're dealing with GIS, this stuff would be important here, but we're not, so we don't need to worry about that. You can read about it in the user's guide if you'd like. We just go to the Interpolate New Cross-Sections. And notice here we've got 2 cross-sections. When I hit Interpolate New Cross-Sections, it fills in those spaces linearly with other cross-sections, interpolated cross-sections. And notice that they're in gray. That's so you can always tell the difference between your interpolated cross sections and cross sections that are actually based on data that you input. Now, if you don't like this, you can always delete it, take them away. But those looked good to me, so I'm going to interpolate them again, and I'm going to keep it. So I'm going to close. And look what happened to our reach. We see some pretty significant changes. We still have 0 and 1400 river stations, but now we have 100, 200, 300, 400, etc. 100 meters spacing all the way up to our upstream boundary. The other thing to notice is that they all have these asterisks. The asterisk denotes these are interpolated cross sections. Okay, it's similar to what we did before. We might want to check to make sure that everything looks good with these cross sections. So we'll go to the cross section editor. And we can let's start at river station 0, and we can literally scroll through these. And what you're going to see is essentially a prismatic channel. Watch the elevations here. We're going to go to the next cross section, 100. It's shifted by 0.1 meters, which should make sense based on our bed slope of 0.001 and a distance of 100 meters. So each of these is going to shift by 0.1. And notice we see our nice cross section. It kept our Banks stations. It kept our Manning's ends. Everything looks like what we would expect to see, right? And et cetera, all the way up to 1400, right? Okay. And similarly, we can check. Let's look at our profile plot. And we have our elevation change of 1.4 meters. And now notice we have in between the data that we input at river station 0 and at river station 1400, we now have every 100 meters we have an interpolated cross section shown in gray. So this looks pretty nice, right? I'm happy with this, so I'm going to close it. I'm going to close my cross section editor. I would like to save my geometry, so I'll save geometry data. And then I'm going to exit this and just check my XYZ, this three-dimensional plot. So let's have a look at the 3D cross-section. Yeah, let's change this. I messed this up at the end. And you can see, again, our river station 0 moving by 100 up to 1400, and it looks pretty nice. If we combine this with our profile plot of the channel bottom, I feel pretty confident that this is going to work. So at this stage, we have now finished entering our geometry, and we learned a couple of very important tools: copying cross sections, adjusting the elevations uniformly across the cross section saved us a little bit of time, and then the interpolation of cross sections saved us a lot of time. We were able to insert 13 new cross sections basically by clicking a button, and that is a very, very useful tool, particularly for the type of prismatic channels that we will be dealing with in this class. Okay. Geometry is done. Next step is to input the flow data, which will be the next tutorial. And I'll see you then. Oh, we should save the project, right? Sorry about that. All right, now I'll see you then.